Hi, this is Miss Erickson back with another video for you for 8th grade physical science. In this video we are going to learn how to make free body diagrams. Our guiding question is, how can we model the different forces that act on an object? So by the end of this lesson you will be able to draw a free body diagram and identify the forces acting on an object. In order to do this, we need to review and learn some vocabulary. One of the words that we need to know is something called air resistance. And air resistance is the force of the air acting on an object. So we see in this picture we have a skydiver falling down from the sky, and he's got a parachute, and that parachute is helping him not fall as fast due to gravity. And that air is catching in that parachute, and that force going upward we're going to call air resistance. And we're going to consider that a push, or gravity, is a pull. Another word of the day that we need to know about is friction. Friction is that force that makes some surfaces harder to move than others. So if you've got a box and you're moving it on tile, it's not as hard to move as if you've got it on carpet where there's a higher source of friction. So friction is just the force exerted by a surface as an object moves across it or tries to move across it, because sometimes we don't actually get the object to move. Big thing here, and we're going to see later when we draw our diagrams, is that friction is always in the opposite direction than the motion. Okay. Last word of the day is something called a tension force. And this is when a string or rope, cable, or wire pulls on an object. Most of the examples we're going to do today are going to be tension forces that go up and down and work against gravity. But we can also have tension forces, like a lot of the examples we have regarding tug of war, okay, or this example where we have this cable holding up this box. Okay, so we're going to start by first defining what is a free body diagram. And a free body diagram is just a simpler diagram to show all the forces that are working on the object. And we show these forces as something called vectors. The longer vectors show larger forces, and the short vectors show smaller forces. So for example, these arrows are the vectors. It's showing both how big they are, but also the vectors show the direction the forces act on. So in order to make these diagrams, you first have to know what all the different forces are that could be acting on an object. The ones we're going to be concerned about are just a handful of them, 5 or 6 of them. The first one that we want to know about is gravity. Every single object that you draw in this class, you are going to have the force of gravity. Every single time, so get used to it. So the first one you're always going to do is you're going to draw a dot, and sometimes instead of a dot, you might find these things as boxes as well. But don't worry about that. Sometimes it'll be a dot, sometimes it'll be a box. So we're going to first draw our arrow down, and then we're going to label the type of force it is. In this case, this is the force of gravity. This is always going to be there. It's going to be the first one you always draw. You can abbreviate it as F with subgrav, or mg, which basically stands for the mass times gravity, or the force, and write out the whole entire word. Another force that you're going to use almost always is something called a normal force. And this is the opposite of gravity. It's working in the opposite direction sometimes. So this is going to be either up or at a right angle to the ground. Okay, when you're going to use this is when any object touches the ground. I would underline that big point. Okay, anytime an object touches the ground. If it's flying through the air, you're not going to use it. If it's touching the ground, you're going to use it. And if it's just on a flat ground like this, it's just going to go straight up. If it's on a ramp or some sort of angle, it's going to go perpendicular to the ground, okay, or at a right angle. Next, what I'm going to do is show you a video that helps explain gravity and normal force when we make these free body diagrams.
What are the forces acting on you right now? I want to answer this question by introducing something called a free body diagram. This is a sketch that scientists make that shows all the forces acting on an object. Each force is represented by an arrow. The size of the arrow represents the magnitude of the force, and its direction indicates the direction of the force. So for example, right now, there is a downward gravitational force on me that pulls me towards the center of the Earth. There's another force that a lot of people don't think about, but it's pretty important, and it's the force from the ground pushing me upward. For most people, it's kind of strange to think that the ground, which is something inanimate, could be putting a force up on me. But let me try to convince you that the Earth really is pushing up on me by stepping on this toy here that's supported by a spring. As I step onto the spring, it contracts. So you can imagine the spring must be trying to expand out and put a force outwards. So that force, in effect, supports me, pushes up on my feet, and balances the gravitational force down so that I remain motionless. Now the ground is very similar to this spring. The ground is just a very stiff spring, but every time you step, you compress the ground a little bit, and that is enough to make the ground create a force on you, pushing you back up. And the force of the ground upwards must be equal to the gravitational force downwards so that you stay at rest. For simplicity, we draw all forces acting through the center of mass of an object. So even though the force is acting on my feet, I can draw that force upwards as acting through my center of mass. So there are really only two main forces on you: the force of gravity downwards and something we call the normal force, which pushes you back up. The reason we call it the normal force is because the word normal means perpendicular, and the force is perpendicular to the surface that you're standing on.
Okay, so that was gravity and normal force. We have a few more forces that we need to learn about. The next one is something called an applied force. This is kind of what you think of as the push or the pull. And the direction is the direction of the movement, usually left or right. But if you're pulling something up, maybe that's an applied force as well, but going up. Or if you're pulling something down, you would have it going down. So when you use this is whenever there is a push or a pull. And the way you can abbreviate that is F applied or F app. Okay, so again, you have your object, you draw the arrow that the force is applied to, and you label that arrow. Another force we have is friction. Friction, remember back from our words of the day, works in the opposite direction of the movement. So when to use this is when any object moves on the ground, it's going to have friction. Even if it's on ice where there's not a lot of friction, there's still going to be some friction. Okay? Abbreviation can be F with an FRIC or F and write out the whole word. Okay, so on this example, we have our object moving to the right, and that's where the force is applied. In the opposite direction of the movement, we have this force of friction. A fifth one, also one of our words of the day, is air resistance. And air resistance, the direction is going to be up. And when you're going to use this is when an object falls in the air. Okay, so you're going to have gravity going down, pulling our object down, and then we're going to have the force of air, or air resistance, going up. Our final force is tension force, and this was also one of our words of the day. So a tension force, the direction you're going to draw this one is most times up, sometimes left or right. When you're going to use this is when a rope or a chain or a wire or a cable is holding something up or pulling something up. So this object can be moving and pulling up, okay? Or it can just be holding it stationary in space. And the abbreviation for this is force and TENS, tension. Okay, so that concludes the types of forces that we're going to do. So next what we're going to do is look at some examples of how we use these forces.